Okay, so we have done variation, indirect variation, direct variation, and versions thereof. We did simplifying rational expressions and multiplying them and dividing them. And then last time we were together, we worked on adding and subtracting. Last time we did new notes. Today we are going to finish up rational expressions by solving equations. If there is an equal sign, you solve it. There are basically two methods for solving. We will cover them both today. So rational equation with at least one rational expression, i.e. a fraction with a variable as part of the denominator. Extraneous solutions, we talked about this. Our domain restrictions refer to extraneous solutions. When we have to basically check our answers in the original problem. We may get answers that don't work, okay, which means that they violate our original domain restrictions. Okay, so those are the things we need to worry about. Now, there are a few ways to deal with rational equations. Anytime I have a fractions part of it, the first problem is a perfect example of what I love to do. Whenever I have a fraction as part of an equation, the first thing I want to do is get rid of them. Get rid of the fractions. And how you do that is you multiply through by the least common denominator. So I have 1/2, 3/4, and 1/8. My least common denominator is 8. So I multiply everything, each individual term, the entire thing, times 8. 8 times each term. Now, 8 times 1/2, half of 8 is 4, so that means I have 4x. 8 times 3/4 is 6, equals 8 times 1/8 is 1. So I have x. And then 8 times 3, 24. Look, no more fractions. First step, multiply through by your common denominator. No more fractions. Easy peasy. Just solve it. Subtract x from both sides. Subtract 6 from both sides. And I get 3x equals 18 divided by 3, and x equals 9. Now, I do need to take my answer and look to make sure I don't have any problems, and I don't because I don't have any variables in any of my numerators, so it doesn't really matter. Okay, no variables in no variables in any of my denominators, so I don't have to worry about extraneous solutions on this one. 9 works just fine. But that's your first step. Get rid of, 6. Thank you. I don't know why I was thinking 9. Maybe it's kind of funny dyslexia and stuff. I see upside down. I don't know. Not to make fun of dyslexics at all. They have their problems. So yeah, x equals 6. It works just fine. But you see what I'm saying? If you get rid of the fractions, no more fractions, you just have an easy equation to solve. First thing you do. This works all the time. If I have an equation to solve that has fractions, my first step is to get rid of the fractions and then solve the equation without fractions. I may get a fraction as my final answer, but I don't care at that point. I won't get it again until my final answer. Okay? So that's the first example. Now, there is a big difference between, I'm going to move that down to get out of the way, between example A and example B. The big difference being is how many fractions do I have in A compared to how many fractions I have in B. In B, I have a proportion. Okay? and B, I have a proportion. Which means I don't have to multiply through by the common denominator. Because how can we always, what can we always do to solve any proportion? Cross multiply. This only works if I have one fraction on each side of the equal sign. So you have to pay attention. If I have more than one fraction on each side of the equal sign, I cannot cross multiply. Here, I can cross multiply. That's all I do. Cross multiply. So I have 4 times 2h plus 4. 4 times 2h plus 4 equals 5 times h plus 2. 5 times h plus 2. Situational. Okay. 8h plus 8 equals 5h plus 10. Subtract 5h. Subtract 8. And I get 3h equals 2. Divide by 3. H equals 2/3. Now, I have to check my answer. If h is 2/3, do I get 0 in either denominator? Yes, question. All right. 16 minus 16 minus 16. So I get 3h equals negative 6, right? Am I right? 10 plus 8, is that negative 6? Did I get it right? Divide by 3, h equals negative 2. My bad. Now, will that give me 0 in the denominator? Yeah. So this one doesn't work. That was my only solution. And if my only solution does not work, that means I have no solutions. Nothing works. It will never be true. There is no number h that will make that work. Because the only one that came up algebraically is an improper answer. It's an extraneous solution, won't work. So there isn't anything that'll work. Nothing will work for that. Okay? Third one. Got a couple of choices on this one. Got a couple of serious choices on this one. Okay? Look very carefully. I have a proportion, right? So I can cross multiply and solve. That would be very ugly, would it not? If I were to cross multiply, that would be very, very ugly, would it not? Because I'd have a y cubed in there, and I'd have to deal with all that crap. But take a very close look at this particular equation. What is unique about this particular equation? The denominators are what? The denominators are the same. And if the denominators are equal, if I have two equal fractions and the denominators are equal, what has to be true about the numerators? They also have to be equal. If my denominators are equal, then my numerators have to be equal. If I have something over 2 equals something over 2, those two somethings in the numerators have to be the same, right? So if my denominators are the same, my numerators have to be the same. Which means I can just say, hey, y minus 1 equals y squared plus 2y minus 3. This is unique only because this and this are the same. If those two are equal, the numerators have to be equal. So you want to play it smart, right? If you notice something like that, hey, I don't have to worry about cross multiplying common denominators, none of that crap. Just that the numerator is equal. Okay, and solve that. I have a quadratic, which means it has to be set equal to 0. Subtract y and add 1. Subtract y and add 1. 0 equals y squared plus y minus 2. Extend to give myself some more room. Okay. Factor. 0 equals two numbers that multiply to give me 2. My only choices are 1 and 2. One's negative, one's positive. They had to give me 1 plus 2 minus 1, which means that y equals the opposite of this, negative 2, and y equals positive 1. Now, what do I always do with my answers? Check them. Can y equal negative 2? No, because if I put negative 2 in my original problem, I'll get 0 in my denominator. Can y equal 1? Yes. It doesn't give me 0 in my denominator. Now, it does give me 0 in my numerator. That's okay. That's okay. I can have 0 in my numerator. That's fine. Just can't have 0 in my denominator. Okay? Questions so far? It's not as bad as it looks, is it? Okay, not as bad as it looks. Don't worry. It'll get, well, it just got worse. Okay. So, I don't have a proportion, so I can't cross multiply. I do not have the same denominator across, right? So I cannot just set the numerators, ignore the denominators, which I could if they were all the same. Even if there's 3 or 4 fractions, I can just, if all the denominators are all the same, just ignore them. So I need to get rid of my denominators by multiplying by the least common multiple. My first step is to factor anything I can factor. M squared minus 9 is m plus 3, m minus 3. Okay. Moving that problem just freaked out everybody who's going to watch the video without hearing anything. To just move without any sound. Think about it, because they only see the screen. If you watch the videos, it's just the screen and my voice. So when something moves, yeah. All right. So here's the deal. What's my common denominator? What has every factor that's in there? Every factor, every denominator. And remember, there's the unwritten parentheses around these. Every factor needs to be included. So here I have an m minus 3. So I have to have an m minus 3. Here I have m plus 3. So my common denominator has to have an m plus 3. This one has an m plus 3 and an m minus 3. So my least common denominator is actually m plus 3 times m minus 3. So that's what I multiply times every term. Now, when I have a complex fraction like this one that's very complex thing, remember on the first example, I just did times 8 times the whole thing, because that's the basic fraction. This one's a little more complicated. I do m plus 3, m minus 3, m plus 3, m minus 3. M plus 3, m minus 3. That's what I'm multiplying times every term. The reason I did that is because when I multiply this times that, things will cancel. My m minus 3's cancel. So for my first fraction, what do I have? I have 2 times m plus 3. My second fraction, the m plus 3's cancel. Equals, sorry, not equals, plus, my bad, plus 2 times m minus 3 equals. And then the last one, look what happens here. Everything cancels. So I get 4. No more fractions. Distribute, combine up like terms, and solve. 2m plus 6 plus 2m minus 6 equals 4. 4m equals 4. M equals 1. Fairly straightforward at that. Once you get rid of the fractions, it's not too bad. Getting rid of the fractions, that's the part you got to be careful about. Can m be 1? Yeah, 1 won't give me 0 in any of my denominators, so I'm good on that one. Okay. Once again, everybody at home, just freak out. Okay. My common denominator on this one. Can I factor d minus 3? No. So my denominators are what they are. They're not factorable. There is nothing I can reduce with or anything like that. So my common denominator on this particular problem is 5 times d minus 3. Because if I were to add these, what would I need to do? I'd need to put a 5 here, and I would need to put a d minus 3 here, right? So that's what I'm doing it by. So 5 times d minus 3, 5 times d minus 3, 5 times d minus 3. Once again, I write, when I have a complex problem like this, I write what I'm multiplying each fraction by next to each fraction, so I don't miss something. And then I do any canceling I can do before I multiply. My d minus 3's cancel. And so in this one, I get 5 times d. So I get 5d. And then plus. Here my 5's cancel. So I have 2 times d minus 3 equals. Here my d minus 3's cancel. And I get 3 times 5, which I think we can decide that we can go ahead and put 15 down for that. You follow me on what I just did, because that's the hard part. That's the hard part. If you can get that down, the rest of it's easy. But you got to get this down first. Okay? Distribute. 5d plus 2d minus 6 equals 15. 7d minus 6 equals 15. Add 6. 7d equals 21. Divide by 7, and d equals 3. Can d equal 3? No. No solution. Always check. Always, 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 always check. What's my first step? What? Factor. Factor my denominator on the one that's not factored. And here's what I'm hoping. Hoping that my two factors are plus 2 and minus 5. Because if it's those, it makes my life so much easier. If it's not, oh, that sucks. So probably is, check to make sure. 2 plus negative 5 gives me negative 3. 2 times negative 5 gives me negative 10. That makes life so much easier. Could you imagine if they didn't factor out the same? You'd have some great big long nasty thing to deal with. Oh, and it'd get ugly in a hurry. So what am I multiplying times everything? Y plus 2 times y minus 5, because that covers everything that's in every denominator. Y plus 2, y minus 5, y plus 2, y minus 5, and y plus 2 times y minus 5. And like I said, I always try to write them down. Go from there. When you do your multiplying and simplifying and canceling and all that good stuff. So y plus 2's cancel. And I get y times y minus 5. My y minus 5's cancel each other. Plus 7 times y plus 2. And here everything cancels and I get equals 14. So far so good. Distribute. Y squared minus 5y plus 7y plus 14 equals 14. Combine like terms. Y squared plus 2y equals, plus 14 equals 14. Okay, if I have a quadratic, what does it need to be? It needs to be equal to 0. Subtract 14 from each side, and I get y squared plus 2y equals 0. And this is one where students screw up all the time. Ooh, I just add 2y, subtract 2y from both sides, divide both sides by y, and I get y equals -2, which is one of two answers. There's still two answers here. This is factorable. You have a quadratic, you factor your quadratic. I have a common factor. Y times y plus 2 is equal to 0. Set each factor equal to 0. Y equals 0. Y plus 2 equals 0. So y equals 0 and y equals -2. Can y be 0? If I put 0 in my original one, am I okay? Yeah. Doesn't give me 0 here, doesn't give me 0 here, doesn't give me 0 there. So that's good. Can y be -2? Nope, can't be -2. It's no bueno. Not one good answer, one bad answer. Questions? Okay. Your turn. Do these two first. No, I don't want to go back and do it all over again. Here's what I'm going to do. I'm going to go back. Now I got the recorder on. So on the first problem, because I failed to record the actual work, first problem I multiplied through by the common denominator of 6. When I multiplied through by 6, I got 1 plus 4x plus 3x equals plus 6. Subtracted 3x, subtracted 1, I got x equals 5. On the second problem, I cross-multiplied to get 4 times a plus 4 equals 3 times 2a plus 6. Distributed, got all the signs on the right side, and I got a equals -1, which works. Okay. And so you have how many? 1, 2, 3, 4 problems. Okay, so how many are done with C? Okay, so keep working on those. I'll give you some more time. Okay, let's finish these off. So, example number C, once again, this is one where our denominators are already equal. M minus 3, M minus 3. So all I need to do is just set the numerators equal. M plus 4 equals M squared plus 6M plus 8. Set it equal to 0, subtract M, subtract 4. So I get 0 equals m squared plus 5m plus 4. Two numbers that add to 4, multiply to give me 4, that add to give me 5 are 1 and 4. 0 equals m plus 1, m plus 4. So m equals -1, m equals -4, and both of those are good. Neither one of them will give me 0 in my denominator. I'm okay with that. Okay. Questions? Okay, next one. What? It can be -1 because it won't give me 0 in my denominator. I don't care about the numerator, I only care about the denominator. And both of those do work. Okay, so this one. I can't cross multiply. It's not a proportion, so I need to multiply through by my common denominator. My common denominator in this case is m plus 2 times m minus 2. So I multiply by m plus 2, m minus 2, m plus 2, m minus 2, m plus 2, m minus 2. And my m plus 2's here cancel, so I get 6 times m minus 2. My m minus 2's cancel. I get plus 6 times m plus 2 equals 4 times, and m plus 2 times m minus 2 is m squared minus 4. Distribute 6m minus 12 plus 6m plus 12 equals 4m squared minus 16. My plus and minus 12 cancels. And I want to set it equal to 0, so I do 6m and 6m and add them together. And I get 0 equals 4m squared minus 12m minus 16. Now, this looks really nasty, does it not? It's not. Divide everything by 4. Divide 0 by 4. Divide this by 4. Divide that by 4. Divide everything by 4. And you get, and I'm moving up here, so I've got room to work. 0 equals m squared minus 3m minus 4. Because I can do that. I can divide everything by 4. Everything is divisible by 4, including 0. Divide everything by 4. Now I can factor. Two numbers that multiply to give me -4 that add to give me -3. Minus 4 plus 1. So m equals 4, m equals -1. Can m be 4? Can m be -1? Yeah, so both of these are good. Move this one out of the way temporarily. So, same thing on the next one. What's my common denominator? T minus 3 times 4. So I multiply everything times 4 times t minus 3. 4 times t minus 3. 4 times t minus 3. Everything gets multiplied by 4 times t minus 3. That's my common denominator. I cancel. T minus 3's cancel. I get 9 times 4, which is 36. Equals t minus 3's cancel. 4 times t minus 4 is 4t minus 16. Here my 4's cancel, so I get plus t minus 3. Combine up like terms. 36 equals 5t minus 19, right? Add 19 to both sides, and I get 55 is equal to 5 t, is that right? 55? Divide both sides by 5, and t equals 11. Can t be 11? So we're good. Questions? I see confusion. Why do I see confusion? Am I good? And then your last one. My first step on this is to factor. Hopefully my factors are v minus 1 and v minus 2. And as a matter of fact, they are v minus 1 times v minus 2, because negative 1 times negative 2 is 2. Negative 1 plus negative 2 is negative 3. That's what my factors are. So my common denominator, fortunately, v minus 2, v minus 1. v minus 2, v minus 1, v minus 2, v minus 2, v minus 1, v minus 2, v minus 1, and multiply and cancel. V minus 1's cancel. I get 4v times v minus 2 minus my v minus 2's cancel, 5v times v minus 1, and here everything cancels, equals 2. Distribute. 4v times v, 4v squared. 4v times negative 2 minus 8v. Negative 5v times v minus 5v squared. Negative 5v times negative 1 plus 5v equals 2. Combine like terms. Negative v squared minus 3v equals 2. I want it equal to 0, but I want my squares to be positive. So I add v squared and add 3v to both sides to give me 0 equals v squared plus 3v plus 2. Zero equals v plus 1, v plus 2. So v equals negative 1, v equals negative 2. Can v be negative 1?
Yeah.
Yeah, it can't be positive 1, but it can be negative 1. Can v be negative 2?
Yeah.
Yeah, can't be positive 2, but it can be negative 2. So both of these are bueno. Questions? Okay.